Hey folks, how's it going? This is Mr. Murray coming to you with a do now for March 23rd, 2020. Okay, this is for Course 2 Honors. So in this do now, what we're going to go ahead and do is we are going to look at this word problem and try to see if we can solve it, okay? So you have set up a ramp in the shape of a scalene triangle. The longest end, which is the one that people walk up, okay, is 8 feet long. The side of the triangle that lies against the ground is 3 feet long, and the final side is 7 feet long. Find the angle between the longest side and the side touching the ground, which is indicated here by using the sign or the symbol theta, and theta is usually, remember, what we use when we talk about an angle. Okay, so what I want you to go ahead and do is I want you to try to pause the video, but before you do, please make sure you have the note sheets available. So what you're going to need is make sure you have all of your note sheets available, including the stuff we talked about, trig, right, with SOHCAHTOA. Make sure you have your Law of Cosines notes available. Make sure you have your Law of Cosines notes available. One of these three you will need to solve this problem. I won't tell you right now, but one of these three you're going to need. Okay, so what I want you to do, I want you to try to use your notes. This completely open note, but what I want you to do is pause the video, try to solve this problem, and then when you're ready, unpause, and we'll see if you were right. All right, so actually, as it turns out, if you can solve this, hey, you're ready for my college pre-calculus class, because this question came directly from my final exam for college pre-calculus. So this is exciting. This is big stuff. If you got this right, I'm really, really proud of you. You should come and sit in on my UMass Boston pre-calculus class because you're there. So what you need to know is, first of all, let's see if we can figure out, do I use SOHCAHTOA? Do I use Law of Cosines? Or do I use Law of Cosines? Okay. If you said SOHCAHTOA, it's not. This is not a right triangle. You cannot use SOHCAHTOA. That only works for a right triangle. Tempting though, right? All right. Law of Sines. Can you use Law of Sines? Cannot use Law of Sines because you cannot solve because you're given a side known information that is not where you use Law of Sines. Recommendation, if you didn't know that, go back and take a look at the notes from the last week's hangout, because I got a really cool flow chart that the book actually provided that tells you, based on the known information, do you use sines or cosines? The law of sines, the law of cosines, okay? So since the given information is side, the law that you use is you must use the law of cosines, okay? Now, it doesn't matter what you call each side because the law of cosine, because in this case, I haven't indicated what's A, B, and C. So I call it whatever you want. Let's call this A, let's call this B. As long as you have the right setup, it doesn't matter what you call the sides if I haven't told you what they are, okay? So what I know is that I want the one with cosine A in it. So I know that A squared equals B squared plus C squared. That's our normal right triangle, minus, because it's scalene, 2AB cosine, or rather 2BC, because this is the A squared, 2BC cosine of A. So if you go back and look at the law of cosines, for the little letter, you'll see the two other little letters, and then for the cosine, it will always be the corresponding big letter. Okay, that's the best I can word this at right now. So if we look at it, because this is big A, 7 is little a, 3 is little b, and 8 is little c. So you can see by looking at this that I have every bit of known information that I need in order to solve this problem. Now, if you have your notes from the law of cosines, you might have seen that we actually derived the formulas not only for finding the side lengths, but also for finding the angles. And I encourage you to take a look at that if you haven't seen it, though I think we may have also discussed it in the Hangout. Okay, so by getting cosine A alone, we knew that, and this is actually, I believe, how we derived it, by getting cosine A alone, and then we extended it from there. So what we know is that by just simply subtracting b squared and c squared, and then dividing by negative 2bc, what we get is we get the cosine of A, okay? And then so therefore, we'll use our inverse cosine to figure out the answer. In this case, I just do want to forewarn, I did not necessarily specify the amount of digits that we're going to use here. In this case, it's not going to matter right now, the precision, because we're only working with whole numbers. But if anyone was like, hey, Mr. Moray, you know, how many things do I round to? That's a fair question. And in fairness, I didn't say that in advance. So we'll talk about that in just a minute. So A is 7, which means that A squared is 49. B is 3, which means that B squared is 9. C is 8, which means that C squared is 64. Then on the bottom I have negative 2 times B, which is 3, times C, which is 8. Okay? And that's cosine A. So my recommendation is, whenever you're given a figure, like a picture, like what I gave you here, mark it up. Because look, if you take, how many seconds did it take me to put little big A, big B, big C, little a, little b? Couldn't have taken me more than 10 seconds. It will save you a world of stress, because now when you're going to plug in, look, what's C? Oh, it's 8. Oh, look, what's A? Oh, it's 7. It saves you so much time. I promise you it's worth it. Okay, so let's see if we can start to figure this out. Now remember, my strategy is you always do one piece at a time on your calculator, because it's going to save you time. Again, it's going to save you time. It's going to save you a headache. So I'll do negative 24 first. And especially because we're not working with any decimals where we're dealing with intermediate results, you know what I mean? There's no rounding that's really going on. Oh, interesting. Oh, negative 24 over negative 48. That's the cosine of A. And that means that the cosine of A, well, we can do negative 24 over 48. It's 1/2. Now, let me show you the mistake people make sometimes. They do 49 minus 9 minus 64 divided by negative 2 times 3 times 8. So you see what they're doing? They're trying to do everything in one step. Now, we know the answer is supposed to be 1/2. We just found that out. They got 808, nowhere close to the right answer. And in fact, if you do the inverse cosine on 808, watch what's going to happen, because that's what you need to do at this point. 808, close. Watch what happens. It's not going to work. And that's because cosine, inverse cosine rather, has to be a number between -1 and 1. Okay? So therefore, and we might not have known that, but that's what the truth is in terms of that. So basically what that means is that you have an error. And the reason that happened was because the calculator goes, all right, let's do PEMDAS. Oh, look, division. So what you want me to do is you want me to take 64, you want me to divide it by -2, then you want me to multiply the answer by 3, and then by 8, and then you want me to subtract. But that's not what we want to do. We want to do this top, then the bottom, then the division. So the only way this is going to work correctly is if you do this. 49, see what I did? I opened up a parenthesis. See how I open up that parenthesis? Down on the bottom, -2 times 3 times 8, close parenthesis. Now I get 0.5, which is the right answer. But think about it. That in the time it took me to just explain that, and the time it took me to get the error, and the time it took me to do it twice, I could have just done the top and the bottom, and I could have done that division in my head. So just think about that. All right? So we know that the cosine of A is 1/2. So what that means is that A is equal to the cosine inverse of 1/2. So in other words, cosine inverse is going to tell me what angle has a cosine of 1/2, and the angle with a cosine of 1/2 is 60 degrees. Okay, so therefore the angle between the ground and the ramp is 60 degrees. Okay, now people might be asking, Mr. Murray, but look, isn't it supposed, we know when it's 60 degrees, the opposite side is supposed to be x root 3, right? Wait a minute though, that's a special right triangle, so that's not going to apply here. Okay, so what do? First, we looked at the situation. We figured out we can't use SOHCAHTOA because it's not a right triangle, no right angles here. We can't use law of sines because, so basically SOHCAHTOA eliminated law of sines and cosines. That becomes our only options. We don't do law of sines because we don't have enough information. It's a side given scenario. So law of sines is out. So we must use law of cosines because you got to believe that if I give you a problem, okay, I have to give you everything you need to solve it. And that means that the given information has got to be solvable with SOHCAHTOA, law of sines, or law of cosines. All right, so I hope you were able to get this due now right. Again, the answer is that theta is 60 degrees. Okay, hopefully you're able to get that. If not, please go back and check your work and ensure you're able to get that right. And today we're going to go ahead and move on to start talking about bearings, which is an application of a law of cosines. Okay, so folks, keep it up. Keep asking the questions. I'm looking forward to a great conversation this week. And remember, you can do it. All right, thanks for watching. Feel free to subscribe so you can stay updated with my newest videos. Have a wonderful day. Don't forget to love math.